welcome once again. I think we'll be going with the same chapter, that is programming of 8085. I think we are going with the last topic of arithmetic group of instructions. I think in the previous group we have already seen the instructions like I think addition, subtraction and all. I think this is the last group, that is increment and decrement, decrement, and let's see what are the other instructions. So increment, we are having INR R, INR M and INX. I think X means register pair. So INR means what? R is equal to contents of register will be incremented by 1. So here we can use any of the 7 registers. R is equal to R plus 1. Then increment M means M is contents of memory will be incremented and it will be stored in memory, and same way register pair will be incremented by 1 and it will be stored. So suppose if I write INR B, so INR B means B, contents of B will be incremented by 1. So it doesn't means like B plus 1 is C. Okay, so whatever the contents are there, that will be incremented by 1. For example, let accumulator is equal to, let B register is equal to 55. This is before execution. If we increment it by 1, so this is in binary 5 that is 55 plus 1. So 1 plus 1 is 0, carry 1. Okay, then rest of the things will be same. So can you see it has been incremented and the new value is 56. I hope it is very simple. Okay, same way you can use other registers, A, B, C, whatever the registers you want. I think I have not taken the example of INR M and all, but let's go with INX RP. RP stands for register pair. So one of the register pair will be there, like INX B. So BC plus contents of BC will be incremented by 1. So let's assume that BC is equal to AFFFF. This is before execution. Suppose if I write, if I try to add 1, so 1 plus 1 is 0, carry 1, 1 plus 1 is 0. Till here it will be 1 only. Okay, everything will be 0. Okay, then can you see 1 plus 0 plus 1 is 1, and this will be like B000H. This is after execution. Okay, now we'll be going with the same concept as increment. We also have a decrement. So DCRR, DCRM and DCX RP. So this will be contents of register will be decremented by 1, contents of memory will be decremented by 1, and contents of register pair will be decremented by 1. So can you see DCRM? So M is equal to DCRM is equal to M minus 1. So M means contents of register pair. I think everyone knows that this belongs to register addressing mode, this belongs to register indirect, and this also belongs to register addressing mode because only register pairs are used. Okay, now contents of HL pair will be having some address. So what is this BA? This is an address. Value is 55. This is before execution. Now when we add up, I think everyone knows, when we subtract, okay, actually subtraction has to be done with the help of 2's complement, but I hope when you do 2's complement also you'll be getting the same output, that is 54 minus that is 55 minus 1, 54. Okay, now this belongs to register addressing mode 1 byte instruction. Okay, DCX, X means what? Register pair. So when we are having pair, so you can decrement the contents of that pair by 1. So BAF0. So when you decrement it, you'll be getting F, and this will I think this will be decremented by I think this is like BAF0. So this will become BAFE. Okay, so when we'll solve it through 2's complement method also we'll be getting the same output. Okay, now we are going with a very different instruction, DAD RP. Now first time you can see we don't have X, still we can see register pair. So add register pair to HL register. Okay, for example DAD, so we also call it as a double add instruction. Okay, this we also call it as a double add, or it is used for 16-bit addition. Okay, like accumulator is used for only 8-bit addition, same way we use DAD for using adding 16-bit addition, because here we use a pair. I think contents of HL pair will be added with whichever the pair mentioned in the instruction. So D is mentioned, that's why it will become DE. So HL is equal to, suppose the contents of HL is equal to AB000. So DE, D is suppose BAFA. So this is before execution. You can write in binary format, and when you add up, so this will be 0, this will be 1 0 1, so this will become A, this will be B, this will be D, and this will be phi, and this is carry. So your answer is actually 1 phi D B A. But register pair, so HL pair will be storing this value phi D B A. So this is the value after execution. This was before execution, now you are having after execution, and remember that the output will be stored in HL pair. Now let's go with the last instruction of this group. This is again a very tricky instruction, DAA, or decimal adjust accumulator. This instruction must always follows an addition instruction before for two BCD numbers. Okay, so it will before you do this, we have to use the addition instruction. It cannot be used to adjust results after subtraction. It cannot be result after subtraction. If lower nibble is greater than 9 or auxiliary carry flag is equal to 1, then add 06 to the result. If upper nibble is greater than 9 or carry flag is equal to 1, then add 06 to the result. If both lower nibble and upper nibble are greater than 9 or auxiliary carry or carry flag is equal to 1, then add 66. Okay, so remember that. Now what do you mean by nibble? Nibble means 4 bits. Like suppose if I write I think this is 0000 and suppose 0010. So this is what 4 bits makes 1 nibble. 4 bit is equal to nibble. Okay, like we are having byte, in the same way we also have bits. Okay, same way we also have bits. So 4 bit means 1 byte. Sorry, 4 bit means 1 nibble. Okay, so 4 bit becomes 1 nibble. So nibbles are like, lower nibble will be I think I'll just give you an example. So suppose I think this will be the perfect example. I think this will become lower nibble and this will become higher nibble. Okay, so this 4 bits will be having 4 bits makes 1 nibble. This is lower, this is higher. Okay, now let's take continue with the example. If lower nibble is greater than 9 or auxiliary carry flag is equal to, these are the rules. Okay, if lower nibble is greater than 9 or auxiliary carry flag is 1, I think when we'll see the example, that time it will be more clear. Then add 06 to the result. If upper nibble is greater than 9 or carry flag is equal to 1, then add 60 to the result. If both are greater than 9, or lower or upper nibble, or auxiliary carry flag or carry flag is equal to 1, then add 66 to the result. Okay, now let's take one example. Now let's add two BCD number 39 and 12. So when you add 39 and 12, I think 9 plus 2 is 1. That is 39 plus 12 is 51. So we have to write directly 3 and 9. This is 1 and 2. Now when we add up, so you will be getting that this, I think 1 plus 0 is 1, 1, 0, 1, and this will be 1 plus 1 is 0. So this will be 4. Now can you see this is greater than, since the lower nibble, as I was telling you, this is upper nibble and this is lower nibble. If lower nibble is greater than 9, then you have to add 06 to the result to get this answer. Actually we want 51, but we are not getting 51. We got 4 and I think this is like B. Okay, 4B. So but we want 51. So if you want 51, what you should do, add this with this number, whatever the result you got, to 06. Why 0 6? Because according to the rule, this is greater than 9. Lower nibble is greater than 9. So you have to add 0 6. So 1 plus 1 is 0, 1 plus 1 is 0. So I think auxiliary carry flag will be set, and this will become 5. So your answer will be 51. So I hope you can take many examples. Sometimes you will be getting upper nibble as greater than 9. So that time you have to add 0 6. Sometimes they will be less, but sometimes auxiliary carry flag will be set. But you have to stop when you get your correct output. Okay, like you want 51, I think you got 51, but you will not get directly. You have to add first, then you have to add this 0 6. Now who is doing this addition and all 0 6? I think this is done by DAA. So DAA instruction will give you an indication that you have to add up this values and you will be getting this output. So I think in this group we have seen increment, decrement, DAD instruction. I think DAD instruction is very important because it is used for 16-bit addition. Okay, this is used for 16-bit addition. And remember that like how we get the answer in accumulators, same way we get the final answer in HL pair. This is also very important instruction, DAA. This is mostly used for BCD instructions. These are the rules. Okay, I think it is written as OR, not both. Okay, if this is greater than 9 or auxiliary carry flag is set, then only you have to add 0 6. If this is greater than 9 or carry flag is set, then 60. If both are greater than 9 or both are set, then you have to add 66. In this case, I think, can you see only lower nibble is set to or lower nibble was greater than 9. When you take some more examples, you will see different scenario. Okay, so I hope you understood. We'll meet in the next session. Thank you.